Hi everyone, welcome back to Made Easy Academia. So today's topic will be based on complex numbers. In our previous video, we have already discussed about how we can perform operations based on quadratic equations. So here, it's just like expansion of complex number. That is, there are some numbers that can give us a negative root. And if you check them using your calculator, you see that maybe someone will be saying that math error or syntax error. So in mathematics, there's nothing like math error there. So that's why we have what we call complex numbers. So when we're talking about the complex numbers, what do they mean by complex numbers? The complex numbers is just like a combinations of what we call the real numbers at the same times what we call imaginary number. You'll be wondering, what do we mean by real numbers and what do we mean by complex numbers? Imaginary numbers. When we're talking about real numbers, it can be natural numbers, it can be integers, it can be rational, it can be irrational. All those numbers that we mentioned are called real numbers. So when we have a combination of I and what we call real numbers is what we call imaginary number. I will give an example of that. Like let's say we have 2, or we have 3, or we have 4/5, or we have root of 2 or root of 4. If you look at all these numbers, they are comprised of many numbers. Like if you check 2 now, we know 2 and 3, they are what we call natural numbers. Now, if you have 4/5, that one is rational or irrational. Then if you have look at the 2 here too, it's also root 2. When we have root 4, that one is rational. So the combination of the real numbers at the same time the imaginary is what we call complex number. What do you mean by imaginary number? For example, if I have root of -5, you can see in this root, if you press your calculator and check into this, you see that it will be showing you syntax error or the math error. So there's nothing like math error under the complex numbers. Meaning, if I have root of -5, simply this one can be split into 2. I can rewrite this as a square root of -1 multiplied by square root of 5. So the only thing that we base our argument here, how can we split the numbers? With the one with negative, at the same time with the one with positive. So that's what we call complex numbers. So any number in the form, a complex number, we can say a complex number, any number in form, any expression in the form of let's say a plus bi is what we call complex number. So here the a that we use here is called the real numbers. So why the b that we write here, you can see we have I there. So here we have what we call imaginary number. So here it's very simple and straightforward. You don't need to worry about yourself anything here. Just a simple expression. So let me show you how you can recognize this when you are dealing with what do we call quadratic equation. In our previous video, we talked about how we can make use of how we can find the root of quadratic, either using factorization method or using the completing the square method or using the formula. So there are some roots. When you are finding there, you see that it can give you a negative root. Let me give an example of that. Let's say we have x squared plus 1 is equal to 0. Let's assume that I want to obtain the value of x here. The first step, what is the first step here? We are going to firstly correct like terms, right? So if I correct like terms here I can have this one to be x squared is equal to 0. Now, this is plus 1. When the plus 1 come to this side, it's going to become what? Yeah, minus. So that is a -1. Then here I can have x squared is equal to 0 minus 1. We are going to have -1. In mathematics, when we have a square, what can we do to cancel a square? Yeah, that is square root. So if I square the both sides, you can see we have square root of -1. So now if you press the calculator in obtaining this, you will see that it's showing you either math error. It depends on the calculator you are using. It will be showing you either math error or syntax error. So there is nothing like error here under the complex numbers. So that's what we are trying to talk about. How can we make use of this expression more simpler, in a simple way? Now, so you have to take note of two things here. How can we play with I? So I is always beside the imaginary numbers. How can we play with I? Any number without, for example, if I have 2 plus 3i, for example. So that means if I want to evaluate, if I want to expand this, or if I want to explain this The 2 here mean the real numbers, while the 3 here mean the imaginary number. So imaginary numbers and real number make of what we call a complex number. Because in mathematics we have different type of numbers. We are coming to that. We have natural numbers, we have real numbers, we have integers, we have rational numbers, we have irrational number as well. We have complex number. Each number that we mentioned have their own notations. You understand? They have their own notations. If I talk about the integers, it has its own notation, so we are coming to that. Now, so there are some things that we need to take note here. So whenever we see it under the complex number, you will know what they are talking about. For example, if I have a number like, if I have a term like root of -1, just like what we evaluate here, whenever you need a root of -1, this is only the same thing as I. Sometimes we use J, it depends on the expression. So whenever we have a square root of -1, it can be written as I. Let me give you a simple logic. Let's say I have square root of -4. So can you help me to press this one using your calculator? Yeah, if you press it, you see that it is showing you math error or syntax error. So now, how can we now break down this one? Using the same logic, I can write this as a square root of -1 multiplied by 4. You know, if I multiply 4 times 1, of course, you are going to have what? You are going to have 4. Now, here, I can break this one into 2. Under solved, if I have square root of AB, let's say we have square root of AB, this can simply be written as a square root of A times a square root of B, just like the two numbers. If I have square root of AB, it can be written as a square root of A times square root of B. Even if I have square root of X, Y, and Z, this can just be written as square root of X multiplied by square root of Y multiplied by square root of Z. So I want to use the same logic, or now I can expand this one now. So meaning, if I have square root of -1 times 4, it can just be written as a square root of -1 times square root of 4. Now, as I mentioned here, whenever we have square root of -1, it is the same thing as I. So this is I multiplied by, we all know the square root of 4, right? What is the square root of 4? Yes, square root of 4 is 2. That is, what two number can we multiply in 2 times to get 4? And square root of 4, we are going to have 2. So here we are going to have 2i. I times 2, we are going to have 2i. Even if the number is not a perfect square root, let's say the number is rational numbers or irrational numbers. Let's say, for example, I have square root of -5. The same logic, I can just say this is the same thing as square root of -1 times square root of square root of 5. So square root of -1, as I told you earlier, is the same thing as I, then root 5. So those are the things that we need to take note in these complex numbers. At the same time, whenever we have I squared, that's the other thing that we have to take note of. Whenever we have I squared, for example, let's say we have I squared. Whenever we have I squared, here it is the same thing as -1. So please take note of these two things. If I have square root of -1, I said it's the same thing as I. And whenever we have I squared, it's the same thing as -1. So the thing now is, it can be I100, it can be I4, it can ask you to find I1000, I raised to the power of 1000, or I raised to the power of 10, whatever they ask you to find. Just know these two expressions, especially the second one. For example, maybe I was asked to evaluate or to find I4, for example. You know, I only have I squared to be -1. It's just a simple logic. Using the indices, I can break this one into 2. I can have this one to be I squared multiplied by I squared, isn't it? Using indices, right? Yeah, fine. So now, if I have this one, I know I squared is -1 multiplied by square root. I squared is also -1. So if I have -1 times -1, you know, remember in our previous video, we talked about how we can multiply the sign together. When we have minus times minus, that one is what? Yes, that one is positive. If I have plus times plus, you see that one is as plus. If you have either plus times minus, or we have minus times plus is a minus. So now, if I have minus times minus, that one is plus. Then if I have 1 times 1, which is 1. So that means whenever I have I4, it's the same thing as 1. I raised to power of 4 is the same thing as 1. So, meaning, in some cases, they might try to complicate the issue. Don't be confused. It's still the same logic. You will be asked to find either I4, I10, I20, I40. I'll break down them one after the other. Let's say, for example, maybe I was asked to find, maybe they said examples. Maybe they said find the value of the following. Find the value or evaluate the value. Find the value of the following. First one, we have I10, I20. Maybe they said, let's add more. Maybe they said I40, maybe I100. Anyhow, we bring it. So now let's evaluate all this. Something like I, we normally use that one to demarcate for complex numbers. Now, you know, we only know 2. Now, if you have I squared, we say the same thing as a minus 1. And whenever we have square root of minus 1, it's the same thing as I. You'll be wondering, so why is it now I10, I20, I40? Even if care is not taken, we even have to find maybe high 1000. Or let me even add more to make it more interesting. Maybe I was asked to find I101. Or let's say I was asked to find I103. Any power, it might be any power. I raised to the power of 103. You might say I raised to the power of 1000 or I raised to the power of 2 million. So once you know the logic of this, how you can play with I, you'll be able to get your result. Now, let's take a look at the first one. Now, in the first one, we are asked to find I raised to the power of 10. So meaning, once I know this, the problem has already become has been solved already. Let's say we have the first one. We are asked to determine the value of I raised to the power over 10. Now, I raised to the power of 10. I'll just break it down. This can be written as using indices. Now I can say this is the same thing as I2. I want to break it down to the lowest term so that you can be able to get it more better. I raised to the power of 2. I raised to the power of 2, you know, 2 plus 2 now will give us 4. I raised to the power of 2, that is 2 plus 2 plus 2. That one is what? Yeah, 6. Now again, 2 raised to the power of 2. That one is what? Yeah, that is 8. Then I raised to the power of 2. If you add all those powers together, let's check all those powers. If truly they are equal to 10, 2 plus 2, that one is 4. 4 plus 2, that one is 6. 6 plus 2, that one is 8. Then 8 plus 2, that one is equivalent to 10. Now, we know from here, from below, that when we have I squared, it's something as a minus 1. So that means I can here operate now I raised to the power of 2, that is minus 1, multiplied by I raised to the power of 2 as well. That is a minus 1. I raised to the power of 2 minus 1. I raised to the power of 2 minus 1. Then I raised to the power of 2 is a minus 1. Even if you like, if you don't want to use 2, so far you know how to play with them. You know, now we have already find out we can find the I squared, I4. I raised to the power of 4. Anyone, either I10, I raised to the power of 10, or I raised to the power of 20. It's still the same thing. Now here, I can firstly go with the sign now, because I know if I multiply 1 million times, of course, it's still going to be what? Yeah, it's still going to be 1. So now, I can firstly multiply the sign together now. Minus times minus. Yeah, that one is plus. Then plus times minus. Remember, minus times minus. We have already mentioned this one earlier. Minus times minus. That one is a plus. If I have plus times plus, that one is still mean as a plus. If I have minus times plus, or I have plus times minus, these two is the same thing as a minus. Now we'll be using this now, so that to make it more interesting. Now, minus times minus, that one is a plus. Now, plus multiplied by minus, that one is minus. Now, minus times minus, that one is plus. So, plus times minus, that one is a minus. So, that means I can have all the sign to be minus. Now, 1 multiplied by 1, multiplied by 1, multiplied by 1, multiplied by 1. You know, if you multiply 1, even in 1 million times, of course, you're still going to have 1. Let's say we have 1 times 1 times 1 times 1, maybe write 1 raised to the power of 1 million. Of course, our result is still going to be 1. So that means if I have I raised to the power of 10 now, it's the same thing as a minus 1. So now, For the second example, we are asked to find I raised to the power of 20. I'll just follow the same logic, the same tactics. If I have I raised to the power of 20, instead of me wasting my time writing I raised to the power of 2, I raised to the power of 4, I raised to the power of 6, I can just break this down into two, that I raised to the power of 20 is nothing but I raised to the power of 10 multiplied by I raised to the power of 10. If I had 10 plus 10 together, of course, we are going to have 20. Now, in the first example, we have gotten that I raised to the power of 10 is nothing but minus 1, isn't it? Now, let's just plug the values. Down here, I can have this. I raised to the power of 10 is minus 1 multiplied by I raised to the power of 10 as well is also minus 1. You can see that we are just using the logic of, we have already gotten the value of I raised to the power of 10. So instead of us wasting our time writing 2, 4, 6, 8, 10, you'll get it, right? So you can just break it down into two. I raised to the power of 20 is nothing but I raised to the power of 10 multiplied by I raised to the power of 10. Now, I raised to the power of 10 is minus 1 multiplied by I raised to the power of 10 is also minus 1. So minus multiplied by minus. Recall that when we have minus times minus is nothing but plus. So here we have plus, then 1 multiplied by 1. I told you, even if you multiply 1 in 1 million times, what is going to be the result? Yeah, it's still going to be 1. So 1 times 1 here, you are going to have 1. And if you have plus 1, the same thing as 1. So that means whenever you are asked to find the value of I raised to the power of 20, it's still the same thing as 1. Now, let's look at if you are asked to find I raised to the power of 100. Let's look at that. You can see that one is much, but it's just a packaging. You can see, even if you are asked to find I1000, you follow the same process. Now, I was asked to find I raised to the power of 100. The int is just make sure you break down the powers into simplest form, since you know that when we have I squared is nothing but minus 1. So for the I20, I can just break them down into simplest way. I can see this is the same thing as I20. If I have I raised to the power of 20 followed by I raised to the power of 20, that is 20 plus 20, that is 40, and we are going to 100. I raised to the power of 20. 20 plus 20 plus 20, that one is what? Yeah, 60. Then I raised to the power of 20. 20 plus 20 plus 20 plus 20, that one will give us what? Yeah, will give us 80. Then I raised to the power of 20. So if you look at this, if you add all this number together, 20 plus 20, that one is what? Yeah, 40 plus 20, that one is 60, plus 20, that one is 80, then plus 20, that one is 100. Now, so the next thing now is to break them down into two now. So now we can have this one to be recalled from the previous example, that we have I raised to the power of 20 is nothing but what? Is nothing but 1. That means that we have 1 multiplied by 1 multiplied by 1 multiplied by 1 multiplied by 1. So, and I told you earlier, even if you multiply 1 in 1 million times, of course, you are still going to have 1. That is 1 times 1 times 1 times 1 times 1. Of course, you are still going to have 1. Even with these three examples, you see that it's more interesting. Even if you have to find I1 million, just follow the same process. The first thing, make sure you know that whenever you have I squared is minus 1. At the same time, how can we play with power? Either I1 million or 5 million or 1,000. Just make sure you know how to. Even, for example, let's say, let me make it more interesting. Maybe I was asked to find I1000, for example. I1000. I raised to the power of 1,000. I can just say this is the same thing as I raised to the power of 200 or I raised to the power. Okay, since I've gotten the I100, let me play with that one. I can say I raised to the power of 100 multiplying by I raised to the power of 100. That is 100 plus 100. That one is 200. I raised to the power of 100, making 300. I raised to the power of 100, 300, 400, 500, 600, 700, 800, 900, and 1,000. So if I add all this one together, 100 plus 100, 200, 300 here, 400, 500, 600, 700, 800, 900, and 1,000. That is multiplications. So recall, in the example 3, we say when we have I raised to the power of 100 is nothing but what? Yes, but 1. So I can just plug them. That is 1 multiplied by 1 multiplied by 1 multiplied by 1 multiplied by 1 1 times 1 times 1 times 1 times 1. So now, if you multiply all this number together, that is 1 times 1 times 1 times 1, they are all going to be equal to 1. So in some example, we will have the result as I or minus I. It depends on the power. Meaning, for example, let's say I want to take a look at, let's take a look at if I have I5, for example, before we solve the next example so that it will be more better. If I have I5, you know, I5 is nothing but I raised to the power of 2, I raised to the power of 2, then I, because 5 is an odd number. You know, in our previous video also, we mentioned how to differentiate between the number that we have in mathematics. We mentioned the even numbers, we mentioned the prime numbers, we mentioned odd numbers, how we can play with them. You know, I said the prime numbers are those numbers that cannot be divided by any other number except 1 and itself. Then we mentioned even number. We say even numbers are those numbers that can be divided by 2. I will mention the odd number as well. We say odd number are those numbers that cannot be divided by 2. So if you look at 5, 5 is a good example of odd number and prime number because it can only be divided by 1 and itself. So now from here we know if you have I square is nothing but minus 1. That means here I can have this one to be minus 1 multiplied by minus 1 multiplied by I, right? So now minus 1 multiplied by minus 1, you know, I told you minus times minus is plus. So now minus times minus is plus. 1 multiplied by 1, that is 1. 1 times I, we are going to have I. You can see here we didn't get, what we got is imaginary numbers. We got I instead of numbers here. So it doesn't matter, just follow the same process, the same logic, the same pattern. Now let's take a look at I101. You see, they mentioned I101 just to confuse you. It's just simple and straightforward. We have to evaluate the value of I raised to the power of 101. We are just going to follow the same process. So luckily for us, we have already got the value of I raised to the power of 100. That means I raised to the power of 101. I can see this is the same thing as I raised to the power of 100 multiplied by I raised to the power of 1. And I raised to the power of 1 is nothing but I. So here, I can have this one to be I raised to the power of 100. See, got that one to be 1. So now we have 1 multiplied by I. So 1 times I, of course, we are going to have I. Now let's look at I raised to the power of 103. I raised to the power of 103. I can follow the same logic. So I can have this one to be I raised to the power of 100, I squared, then I, because you know I means I raised to the power of 1. So if I had 1 plus 2, that's going to be 3, then 3 plus 100, that's going to be 103. So recall, we got the value of I raised to the power of 100 to be what? Yes, exactly. We got it to be 1 multiplied by, then we know that I squared is the same thing as minus 1, then multiply by I. So 1 times minus, that's going to be minus I. So that means if I was also find I raised to the power of 103, we are going to have minus I. So we are going to have more exercises. If we go to materials where we are getting more examples, we are going to have many exercises there. For now, even if we have to find I500, I raised to the power of 500, or I raised to the power of 600, or I raised to the power of 1000, just follow the same logic. So how can we add two complex numbers together? Even in some cases, you may be asked to play with how can you make use of how can you equate the two together? How can you equate them? Maybe, for example, you know, I told you any expression in the form of a plus bi, as I mentioned earlier. Any expression in the form of a plus bi is what we call a complex number. So in some cases, they may now try to complicate the issues. That is, it may be given, let's say we have, for example, let's say we have two sides. We are going to have a number so at one side, we are going to have a complex number at one side, then you just have to equate them. Let's take a look at some questions from the past questions here. Let's take a look at some problems from the past questions and how can we play with them. It's very simple and straightforward. Let's take a look at some problem from this past Q. So for example, let's look at this problem. They said if x plus y plus I, x minus y is equal to 7 plus 2i. Find the value of x and y. You can see this one is another problem that we can be able to solve using a simple logic of that. Now, if you look at this expression, you can see, if you look at these expressions, we can see if you look at the left-hand side, we have x plus y, which indicating the real numbers. We have x minus y of I, which indicating the complex number, the imaginary number. You remember? I told you any numbers, and if you compare them, a plus ab or by, you can see this is the real numbers, and this one is imaginary numbers. So now, if you look at this side too, this is real numbers, and this is also imaginary numbers. So now I can just solve the two now using this expression as well. Now, what I have is x plus y plus I, x minus y is equal to 7 plus 2i. Now, this is x plus y, this is x minus y. So it doesn't matter. What I have is, this is real numbers, this is imaginary numbers. Let me indicate it. This is real numbers, this is imaginary. Look at this one too. This is real numbers, and this is also imaginary. I'll just solve them, compare them. Real number for, I will equate them. Real number for the real numbers, imaginary number for imaginary numbers. Are you following? What is the real number here? You can see the real number here is x plus y, isn't it? And the real number that we have here is 7. So let's equate them. This simply means x plus y is equal to 7. Can you see? That's our equation 1. Then imaginary number for imaginary number, that is x minus y is equal to 2. This is equation 2. Why do we have two equations? Because we have two unknown. I have x to be unknown values as well. I have y to be unknowns value. You can see from one topic we are entering another one. Now we are under the complex numbers. Now we enter simultaneous equations. So now let's see. You can, if solving simultaneous equation, you can use elimination method. You can use substitution method. In maths we have many methods to solve simultaneous equation like Gauss-Jordan, Gauss eliminations, maybe for matrix method. But to make it easier, let's use elimination method here. So to use elimination here, we can add the two equations together. X plus x, that one is going to give us what? Yeah, it's going to give us 2x, then plus y minus y, that one is 0, equal to 7 plus 2, we are going to have 9, isn't it? Now, I'm looking for x. So since I'm looking for x, and the coefficient of x is 2, I can say divide both sides by 2, which means x is equal to 9 over 2. And if you like, you can leave this one in form of our mixed fractions. So since I've gotten x, I can put my x into either equation 1 or equation 2. So if I look at equation 1, what I have equation 1 is let's say substitute or put the value of x into 1. What do we have in equation 1? We have x plus y is equal to 7. So now our x is 9 over 2. That means that we have 9 over 2 plus y is equal to 7. If I collect like terms, that means I can have y is equal. Why do we call it like term? Because I'm looking for y. If I collect like terms, this is plus 9 over 2. When it comes here, it's going to become minus 9 over 2 minus 9 over 2. Now, if I have 7, it's nothing but 7 over 1, isn't it? Now, if I have 7 over 1 now, if I find the XCM of 1 and 2 will give us 2. How many 1 can we get in 2? Yeah, that is 2. 2 times 7 now we have 14 minus how many 2 can we get in 2? Yes, that is 1. 1 times 9 we have 9. So here I can have this one to be y is equal to 40 minus 9. Of course, we are going to have 5 over 2, which means the value of x is 9 over 2 and the value of y is 5 over 2. Let's bring one more examples. Let's just change the alphabet and the numbers that we have at both right hand side and the left hand side so that we can have more examples. How can we play with this complex number? It's very interesting. Now let's look at this. Maybe bring more examples. Let's bring more examples under that before we start from how can we add, subtract two complex numbers together. if, let's look at this, question 2, if a plus b, a minus b is equal to 8 plus 2i. They say find the value of a and b. So we have to find the value of a and b here. It's still the same thing. I will just equate them. If you look at the left hand side, this is real numbers. If you look at right hand side, the real number here is 8. Then here too, I have a minus b to be my real number, to be my imaginary number here, and I have my 2 here to be my my imaginary number as well. You can have, don't worry, you can have this one as 2i or i2. Just make sure that you can differentiate between the real numbers at the same time the imaginary numbers. Now let's solve this. If I go back here, if I have, by comparison, what I have is a plus b plus I, a minus b is equal to 8 plus 2i, right? Now compare them, the real number for the real number. What's the real number here? Yes, the real number here is a plus b, and this one, what about this one? Yes, the complex numbers are the imaginary numbers. Sorry about that. That is our imaginary numbers. This side too, this is real numbers here, and this is our imaginary number. Just equate them. Real numbers for the real numbers as well, imaginary number for imaginary numbers. So now if I equate them, meaning this means a plus b is equal to 8. That is equation 1. Very nice. Then the second one we have is a minus b equal to 2. So we are just equating the real number for the real numbers as well, the imaginary number for imaginary numbers. So let's just quickly use elimination, just like what we used in our previous example. Now a plus a, that's going to give us a 2a plus b minus b, that is 0, is equal to 8 plus 2, that's going to be 10. So since I'm looking for a, I can just say divide both sides by 2, divide both sides by 2, which means a is equal to, how many 2 can we get in 10? Yes, that one is 5. Now, since we have put in the value of a to be 5 now, I can substitute the value of a into either equation 1 or equation 2 to obtain the value of my b. So substitute the values, substitute the value of a into 1. What do we have in equation 1? Equation 1 says that a plus b is equal to 8. Now, what I got for a now is 5, right? So let's substitute it here. That means that we have a plus 5 is equal to 8. Meaning, if I collect like time, we know this is positive. When the positive comes here, you are going to have negative. That is that a is equal to 8 minus 5. That is that a is equal to 3. You can see now the value of a is equal to 3. And the value of, sorry about this. Now, what I have here is a is equal to 5. We can have this one to be 5, then plus b equal to 8, right? Because we have gotten the value of a, sorry about that. Now, if I collect like times here, we have b is equal to 8, then minus 5, which means b is equal to 8 minus 5. We are going to have 3. Now, we have the value of a to be 5, and we have the value of b to be 3. We can check that this result that we got, is it correct or wrong? That's another important of this our Made Easy Academia, that you can still check if what we have on the right hand side can equal to what we have at the left hand side. Now let's go back here now. What do we have for a? Our a is 5, right? Now, and what do we have for b? Our b is 3. If I reach here, I can say this is a is 5. A is 5 as a 5 plus b is 3, and we have 3 here. You can see 5 plus 3, we are going to have 8, which is equal to what we have at the right hand side. Even you can even check for the complex number as well. If for the imaginary number as well, then if I have a minus b, so my a is 5, my b is 3, 5 minus 3, of course, we are going to have 2. So that's another way of getting, when you are asked to compare what we have at the right hand side as well, what we have at the left hand side, using the knowledge of complex number, that is for real numbers as well for imaginary numbers. So how can we add complex? How can we add? Here you may be asked to perform operations using either addition, subtraction, multiplication, anyone, either multiplication or division, you can make use of this approach. Let's see basic operation involving complex numbers. Basic operation involving complex numbers. That is, here what we mean here is how can we add them together? How can we add them? How can we subtract? For example, let's firstly talk about addition of complex numbers. Addition of complex numbers. For example, let's say we have, let me say simplify the following or evaluate the following. Maybe say I will find the value of simplify or evaluate the following. Or find the value of the following. The first one, maybe I have 3 plus 6i plus 4 plus 8i. Second one, let's say we have 10 plus 5i plus 2 plus 3i. Let's say the third one, let's say we have 7 minus 8i plus 2 plus 5i. It's just so straightforward. Note one thing here, either additions, either subtractions. You match them together, that is, real numbers for the real numbers, that is, we had real number for the real numbers, imaginary number for imaginary numbers. If you look at the first one, it's a simple mathematics, simple arithmetic, right? You find it more interesting that why it's so simple like this. That's how mathematics are. It's very, there's something, if you hear the terms, you see, what is this? But trust me, it's just so simple and straightforward, because mathematics is just the study of counting. Now, you see, the real number we have here is 3, and the real number here we have here too is also 4. That means these 3 and 4, they are the real numbers. 6i and 8i, they are the imaginary numbers here. So now, if I have 3 plus 4, we can have that one to be 7. Then if I have 6i plus 8i, of course, that one can be 14i. That's all. You can see I just match real number for the real numbers, as well imaginary number for imaginary number. So this one too, we have another numbers here. This is the real numbers that we have to be 10. These are another real numbers that we have to be 2. So the reason why they put bracket, in some cases we have negative. We are coming back to that. Now if I use plus to open this bracket, this is nothing but 10 plus 5i plus times 2, that's going to be plus 2. Then remember, if I have plus times plus, it's nothing but plus, then what we have is 3i. It has become a simple expression just like the first one. Just add them together, the real number for the real numbers, at the same time the imaginary number for imaginary number. So that is 10 plus 2, and we have 12. Then 5i plus 3i, you are going to have it as 8i. So if you look at the third one too as well, just match them together. That is the real number for the real numbers, imaginary number for imaginary numbers. That is 7 plus 2. Of course, you are going to have 9. Now look at the first number here. You can see the first number here contains negative. So that is minus 8i plus 5i. That's going to be minus 3i. The same logic follow when we have subtraction of complex number. We follow the same logic, that is, we are going to take the real number for the real numbers, as well imaginary number for imaginary number. You cannot add real number together with a imaginary number. No, just match them. If I have real numbers, add the real number for the real numbers. If I have the imaginary numbers, add the imaginary number for imaginary number. For example, that one is also simple. That operation, let's see subtraction of complex numbers. Subtraction of complex numbers. So like this, let's just exactly the same logic. Let's say we have 6 plus 8i minus 2 plus 3i. Look at this. That's what I'm telling you how to this bracket. If you look at this outside here, we have a minus, which means before I perform these operations, this minus will affect the two numbers we have in the bracket here. So meaning I can have this to be 6 plus 8i minus times 2i, we have minus 2, right? Remember, when we have minus times plus, that one is a minus, then we have 3i. So let's merge them together. Real number for the real numbers, imaginary number for imaginary number. That is our 6 minus 2, and we have 4, then 8i minus 3i. Of course, we are going to have 5i. You can see this is real numbers, and these are imaginary number. Even if you are given something more than this, just follow the same pattern. Let's just solve one more examples. Okay, let's look at this. They said if A, okay, let's make it more interesting. Let's make it more interesting. Let's say, for example, they said that let's make it more interesting before we go to multiplications. They say if A is equal to 6i or 6 plus 2i, and B is equal to 5 plus 3i. They said find the value of Roman figure 1, 2a plus 3b, Roman figure 2, 3a minus 2b. Look at this. You can see we are given A to be 6 plus 2i. We are given B to be 5 plus 3i. I will just follow the same pattern, the same logic, the same process. Now, I was given A to be equal to 6 plus 2i. We have B to be equal to 5 plus 3i. It's just another method. Just make sure that you have already known how to add and how can we subtract. Now, the first one, let's approach the first one. The first one, I was asked to find 2a plus 3b. You know, when we have this, the sign that join 2 and a together is what? Exactly, it's multiplication. That is, if I have 2a, is just like 2 multiplied by a. That is, I should multiply 2 by a. Now, let's substitute the value. So here I can have 2. What do we have for a here? Our a is given as 6 plus 2i. Are we following? Yeah. So plus 3. What do we have for b? Our b is 5 plus 3i. So now let's open the bracket of this. 2 multiplied by 6. That one is 12. 2 multiplied by 2i. That one is 4i. 3 times 5, we have 15. 3 times 3i, we have 9i. So you can see now, you can add real number for the real numbers, at the same time, imaginary number for imaginary number. So here, I can have this one to be 12 plus 15. That's going to be 27. Then 4i plus 9i. That one's going to give us 13i. You can see it's straightforward. Now, the second example, the second questions, we are asked to find the value of 3a minus 2b. I will still follow the same pattern, the same logic. We have 3 bracket of my a is 6 plus 2i minus 2. My b is 5 plus 3i. So the same pattern. This is nothing but 3 times 6, that's going to be 18. 3 times 2i, that's going to be 6i. Minus 2 times 5, that's going to be minus 10. Minus 2 times 3, that's going to be minus 6i. Now, follow the same pattern. Real number for the real numbers, imaginary number for imaginary numbers, right? Now, 18 minus 10. What is the result? Yes, 18 minus 10 is 8. Then 6i minus 6i. You know, that one is just 0i. And since it's just 0, you can see this result is the same thing as 8. That is, when we have 3 times 2, we have 3 times 6, we have 18. 3 times 2i, we have 6i. Minus 2 times 5, we have minus 10. Minus times plus, we have minus 2 times 3i, we have 6i. Then I match them together. Real number for the real numbers, imaginary number for imaginary numbers. So 18 minus 10, we have 8. Then 6i minus 6i, we have 0i. And this is nothing but 8. Now, let's see another one apart from addition and subtraction. We still have another one we call multiplication of complex numbers. So recall in the previous example, I mentioned how can we evaluate I squared. You know, I told you that when we have I squared, is nothing but minus 1. So multiplication of complex numbers. Multiplication of complex number. Now, how can we multiply two complex numbers? Recall I told you that when we have I square is the same thing as what? Yeah, the same thing as -1. So please take note of this. I will be using this I square here. For example, they said as you expand, they said expand 2 plus 3i, 5 plus 2i. So I want to evaluate this. So now, I told you, please don't forget, you can say this is I3 is the same thing, or this is just like indicating for the imaginary numbers. Now, let's expand. Simple expansion, meaning 2, we multiply these two, right? 3, we also multiply these two. That means this is nothing but 2 bracket of what we have here. That is our 5 plus 2i plus this, that is our 3i bracket of our 5 plus 2i. We are just trying to expand. Using the first number here to multiply these two. Using the second number here to multiply these two here. So now let's expand now. 2 times 5, that's going to be 10. 2 multiplied by 2i, that's going to be 4i. 3i times 5, that's going to be 15i. 3i times 2i now. 3 times 2i, we have 6. Then I times I, we have I squared, right? Now, so here we have 10 plus 4i plus 15i. They have, this is imaginary number, this is also imaginary number. We can add them together. 4i plus 15i, that surely will give us 19i. Recall, if you have I square, it's the same thing as what? Yes, it's the same thing as -1. So here I can have this one to be 10 plus 19i plus times minus, that's going to be minus. Then 6 times 1, we are going to have. You can see the way we are playing with the signs as well, the I as well. So now let's mark them together. The real number for the real. No, can we add 10 and 19i together? No, because 10 is the real numbers. At the same time, 19i is imaginary numbers. That we can only add, we can only combine 10 and minus 6 because 10 is the real numbers as well. Minus is also real number. So 10 minus 6, we have 4, then plus 19i. That's another way of taking, or even if it might not even be in this case, maybe you ask, for example, let's say we are given something like this. Maybe they say that maybe we have to find, look at this one, we have to find, expand, or find the value of 1 plus 3i all squared. You see, this one too is another logic of that. I'll just follow the same process. So this one can be written as 1 plus 3i, 1 plus 3i. So I don't need to even go back again here. I've told you how to expand, meaning the first one here, we multiply the 2. At the same time, the second one, we also multiply the 2. That we are going to have 1 multiplied by 1, that's going to be 1. 1 multiplied by 3i, that's going to be 3i. 3i multiplied by 1, that's going to be 3i. 3i times 3i, that's going to give us a 9i squared. If I have 3 times 3, that one is 9. I times I, that one is I squared. So here I can have 1 plus 3i. 3i plus 3i, of course, you are going to have 6i. So here, if I have I squared, it's the same thing as -1. Good. So now I can have this one to be 1 plus 6i plus times minus. Exactly, that one is minus. 9 times 1, we are going to have 9. So now, it's left for me now to combine the real numbers together. So if I have, 1 is the real numbers here. At the same time, -9 is also the real numbers. So 1 minus 9, that's going to be -8, then plus 6i. So even if the power is not 2, let's say the power is 3, you should follow the same process. Maybe they say we are given a power like 1 plus 3i raised to the power of 4. I'll just expand them one after the other. I can just say, for example, let's say I have 1 plus 3i raised to the power of 4. I can just put this one into this. 1 plus 3i, 1 plus 3i, 1 plus 3i, 1 plus 3i, for example. So I will solve this first. Luckily for us now, we have gotten this. What we get is -8 plus 6i. So this one too, what we have is -8 plus 6i. Then we now expand it again. Follow the same process. The first one for the first one, the second one for the second one. That's what then whatever you have, that's going to be your final result. So the next one is division. But before we talk about that, we need to talk about what we call the conjugate of a complex number. Just like opposite, conjugate of a complex number, conjugate of a complex number. So we have conjugate, just like the opposite. You know, every word has its own opposite, right? Fine. If I have conjugate, just like opposite of that particular expression. So, for example, if I have 1 plus 2i, for example, if I was asked to find the conjugate of this, that means it's going to become what? Yeah, it's going to become 1 minus 2. I just think the sign between them. If I have 5 plus 2i, that means the conjugate of this is going to become what? Yeah, it's going to be 5 minus 2i. Even with some problem, let's take a look at this, some question from this past Q, and how can we play with that one too. Let's look at this problem. They said, find the sum of the complex numbers. Find the sum of the complex number z is equal to 3 plus 2i. So please, meaning, in some cases, they can use this something like a bar to indicate the conjugate. Are you following? If I have something like this, it can be used to indicate the conjugate. Maybe if you are given a vector like this, or at least a complex number like z, then the conjugate, they can write it as a z bar. So like here now, if I, okay, they said, let's complete it. They say, and its conjugate. So even here, we are given options. Option A, 6 plus 4i. Option B, 6. Option C, 6 minus 2i. Option D, we have it to be 6 minus 4i. You can see, even the option 2, they can even cause another problem. But we don't mind them. Just follow the same process, the way we are going to find it here. So now, I was given z to be 3 plus 2i. You know, I told you, you can use this notation to represent for the conjugate. So that means the conjugate of this is going to be what? Yes, exactly. It's going to be 3 minus 2i. So now we are now asked to find the sum. You know, when we are asked to find the sum, what does that mean? It means to add them together. So let's add them now. I want to find z plus z bar. So what do we have for the first one? I have 3 plus 2i. And what do we have for the second one? We have 3 minus 2i. You can see we have done additions of complex numbers. We talk about subtraction of complex numbers. Just match them together. So this is 3 plus 3 here. You know, 3 is a real number. Another 3 is also a real number. So 3 plus 3, we have 6. 2i minus 2i, that's 0i. And I told you 0i is nothing. So that's, we have this one to be 6. That means the correct option here is going to be equal to 6. So in dealing with imaginary number, even we have another examples here that talk about how can we make use of this. Let's look at this another problem too. They said find the difference. Let's look at this. Yeah, I love this example too as well. That's beauty of mathematics. They can take it from one topic to another topic. Like this type, they said find the difference. Find the difference between the complex number z is equal to 4 plus 5i and its conjugate. You see, it's just simple and straightforward, right? Now, I told you if the z is equal to 4 plus 5i, you normally use this to demarcate for the complex, for the conjugate. So the conjugate of this is going to become what? Exactly, it's going to become 4 minus 5i. So, you know, whenever we have the word different between, what does that mean? Yeah, it means you are going to find the negative, just like minus. If I said find the difference between 6 and 4, meaning 6 minus 4. So now they ask us to find the difference between this complex number and its conjugate, meaning we are asked to find z minus z bar. So now our z is 4 plus 5i. Then I want to subtract this one too from there, 4 minus 5i. So please take note of the minus. The minus sign that we have, we affect the two signs, the two numbers that we have inside the bracket. So that means here I can have this one to be 4 plus 5i. Minus times 4, we are going to have minus 4. Minus times minus, we are going to have plus. Then we are going to have 5a here. So here we have 4 minus 4. That is 0. 5i plus 5i, that's going to give us a 10i. Even we haven't have another one here. They said, write the complex number. I love these examples. They are very nice and interesting. You can see that's the beauty of mathematics. Now let's look at this example too as well. They said, write the complex number 3 plus root of minus 9 in standard form. In standard form. Yeah. So now you look at this one as well. You can see. Just follow the same process. I told you how to break down these two. This can be just written as a 3 plus, this one can be written as a minus 1 times 9. You remember, right? I told you if I have root of AB is nothing but root of A multiplied by root of B. Now, I can break this down now. That's a 3 plus a root of minus 1 times a square root of 9. So now, we are going to have 3 plus root of minus 1. That one is nothing but what? I. Remember, right? Yeah. Very nice. I. Square root of 9, we are going to have it as 3. So by multiplying this together, I can have this one to be 3 plus I times 3. We can have it as 3. You can see that that's how we can play with complex numbers. That is how we can play with conjugate. So in dealing with division of complex number, you need to know how to find the conjugate of the complex numbers. That is, if I have a complex number like let's say 5 plus 5i, if I was asked to find the conjugate, it's going to be 5 minus 5i. That means if I have a positive, it's changed to negative, or if I have a negative, it's changed to positive. So the next thing we are going on is how can we find division of complex numbers.